Probability is a branch of mathematics that deals with the study of random events and the likelihood or chance of their occurrence. It provides a way to quantify uncertainty and make predictions based on incomplete or uncertain information. Probability theory is based on the concept of a probability space, which consists of a sample space, a set of possible outcomes, and a probability function, which assigns a probability to each outcome. The probability function must satisfy certain axioms, such as the probability of any event being between 0 and 1 and the probability of the sample space being 1. Some common concepts in probability theory include 1. Probability distribution. This describes the probability of each possible outcome of a random variable. Common probability distributions include the normal distribution, binomial distribution, and Poisson distribution. There are two types of probability distributions: discrete probability distributions and continuous probability distributions. Discrete probability distributions are used to model random variables that take on a finite or countable number of values. Examples of discrete probability distributions include the binomial distribution, Poisson distribution, and geometric distribution. Continuous probability distributions are used to model random variables that take on an infinite number of values within a range. Examples of continuous probability distributions include the normal distribution, exponential distribution, and uniform distribution. 2. Conditional probability. This is the probability of an event given that another event has already occurred. Conditional probability is often used to model cause and effect relationships and to make predictions based on past data. Conditional probability is denoted by P, A, B, which represents the probability of event A occurring given that event B has already occurred. The formula for conditional probability is P, A, B equals P, A and B, phosphorus monoboride, where P, A and B is the probability of both events A and B occurring together, and phosphorus monoboride is the probability of event B occurring. Some common examples include weather forecasting. The probability of rain tomorrow given that it rained today. In this case, the probability of rain tomorrow is the event A, and the probability of it raining today is the event B. 3. Independence. Two events are independent if the occurrence of one event does not affect the probability of the other event. Independence is a key concept in probability theory and is often used in modeling complex systems. Formally, two events A and B are independent if and only if P, A and B equals P, A, asterisk. Phosphorus monoboride, where P, A and B is the probability of both events A and B occurring together, and P, A, and phosphorus monoboride are the probabilities of events A and B occurring separately. Tossing a coin. The probability of getting heads on the first toss does not affect the probability of getting heads on the second toss. The outcomes of the two tosses are independent events. 4. Bayes' theorem. This is a formula that relates the probability of an event to the probability of another related event. Bayes' theorem is often used in statistical inference and machine learning to make predictions based on incomplete or uncertain information. Medical diagnosis. The probability of a person having a disease based on a test result. In this case, the prior probability of having the disease is P, A, and the probability of testing positive given that the person has the disease is P, B, A. Thanks for watching.